Hello everybody, this is a house circuit, okay? So everybody knows what a house is, the place where you live in, and the circuit is basically a pathway for electricity to pass. So if this over here and then there's a battery over here, coming here. So the whole thing over here, this is an electric circuit, okay? So as you can see there are multiple wires, motors and LEDs. So I'll just show you how it works. So over here we have our switchboard, okay? It contains of one house main switch. So the house main switch does, it shuts down all the appliances. It has the ability to shut down all the appliances or turn on all the appliances. Then we have two floor switches. As you can see in our house, we have two floors, and each floor contains two rooms, and each room contains two appliances, which is an LED and a fan. So the floor switch 1 turns off.
Why don't you show a little before you explain?
Okay.
Just a little that, okay, I'm switching this on, I'm switching that off.
Yeah, I'm just connecting the battery.
You're right in front of the.
I'm just connecting the battery. Connected the batteries, and now when I turn house main switch on, right now so house main switch is on, but the floor switches are off, so no plants will work. Now, turning off everything. Yes, so now I turn the floor switch, nothing works. Now, every room has its own switch. So, every room has a room switch. And like room 1 has a room switch, room 2 has a room switch, room 3 has a room switch, room 4 has a room switch. And room switch contains, can turn off and on the appliances inside the room, which is the fan and the LED. And then each appliance has its own switch, bulb. So here for room 1, there is a switch for the bulb and a fan, and for all the rooms named. So I turn on the room switches. Now I'll turn on bulb 1. It's working. Can you see it? Next, motor. This is also working.
Fine, try another room, it's okay.
Okay, I don't know what's happening. Bulb 2, LED working. Motor 2. And right now the whole floor is working. Okay? So now I'll turn the whole floor off with just a flip of the floor switch. Floor switch off, the whole floor is off. Now I'll show you floor 2. So I've turned on bulb 3 working, motor 3 which is also working, bulb 4 working, motor 4 also working. Now the whole second floor is working. So I'll turn off the floor switch, nothing works. Now I'll turn on all the appliances, floor switch on, floor 2. So now all the appliances are working, right? Now I'll turn everything off by a flick of the house main switch. And when all the appliances are off, it turns off this LED. So this LED is basically a porch light. Like when you're going to sleep, you turn off all the appliances, but you need some little light to when you wake up and all. So that this acts as a porch light. Now, the main thing, how does it work? So, let me just erase this. Yes. So, this is our house. Okay, this is our house. This is room 1, room 2, room 3, room 4. So, these are the 4 rooms. And each room has a motor and an LED. Motor, and an LED. So every room has a motor and an LED. Now, I will just show you the connections, okay? So for the motor, first of all, you need a...
See, Tetish, it's always a good idea to work your things from bottom to up when you are explaining a circuit thing or anything in fact. But what you're doing is you're प्रोजेक्ट ऐसे दिखाना इज फाइन बिकॉज ऑब्वियसली तुम एक सर्किट नहीं दिखाओगे ये देखो मैं सर्किट बनाया, प्रोजेक्ट तो कंप्लीट ही दिखेगा कि देखो ये चल रहा है ऐसे ये स्विच बट व्हेन यू आर एक्सप्लेनिंग यू हैव टू वर्क योर वे अपवर्ड्स, तुम सीधा ऊपर से फिर नीचे आने की कोशिश कर रहे हो।
Okay.
यू नो you first say कि देखो मैं ऐसे करंट को डिवाइड करके I can have two appliances,
Okay.
but then instead of that I can divide it further and then समझाते समझाते then all you have to do is bring those wires to their appliances, see what I have done now.
Okay.
ऐसा वर्क करो उस आइडिया को उनके दिमाग में, अगर सही में एक्सप्लेनेशन चाह रहे, दिस इज आल्सो फाइन जो तू कर रहा है, इट्स जो तुम कर रहे हो वो भी फाइन है, बट वोंट इट बी बेटर इफ यू वर्क दैट आइडिया अपवर्ड्स?
Okay. Okay. So let's say this is a battery, okay? Now you can connect one appliance with this. Everybody agrees on it, right? So then the LED works. But now you can also connect to another appliance like this, with a motor, right? This would also work. The positive terminal.
थोड़ा बड़ा बनाओ यार, या दूसरा पेन ले लो प्लीज।
Okay. Yeah. So if this is a battery, plus and negative, you can turn on an LED like this. But then you can also put another appliance like a motor like this. And now to go even more further, you can keep on attaching appliances as you like. So this is actually called parallel connections. This is parallel connections. As the current is getting divided, it's going through this, this and this simultaneously. Now, if you want to connect these three...
There is this one more problem. Sorry for this real-time feedback. You're not concerned, you do not seem concerned about whether anyone is listening or understanding or not. You're acting like a radio jockey.
So, did everyone understand parallel circuits? Anybody has a question? Not? Okay.
You understood?
Yes.
But how much can you divide the current? You said parallel connections divide the current.
That he will answer. उसको एक बार structure समझाना, that he will answer.
Okay. So this is parallel. Okay, everybody knows that. Now to connect all of these three, you can use another type of circuit which is called the series. And now, so if this is a battery, okay, we will connect an appliance. Then by this negative terminal, we will connect another appliance, and then another appliance, and then only. So in this, the current is not getting divided. The current is going from here, but the voltage is getting less. So what current and voltage is? And talking about those terms, everybody has understood series also, right?
No, you started with your structure. Now let's complete the structure first, not the terminologies and technicalities.
Okay.
Why did you start with the parallel connections? You wanted to understand. You wanted to make them understand how it worked, right?
Yeah.
तो बात क्यों भटक रहे हो?
Okay. So right now here I have done the same thing. So right now in our houses we have various appliances. So let's say this is our house room. You have a LED and a fan. Every appliance has its personal switch, right? Right? Then you also have a switch on basically on a motherboard in your house to turn off the whole room, right?
MCB बोलते हैं उसे, miniature circuit breaker.
Okay.
ये उन स्विच की बात कर रहे हैं जो घर के बाहर स्विच बोर्ड होता है, घर के बाहर होता है, उसको अगर ऑफ कर दो तो पूरा घर ऑफ हो जाता है, उसकी बात कर रहे हैं, ठीक है?
So now I'm just gonna add another room. Now you would also have a switch, I think an MCB only, to turn the whole floor off, right? Right? Now I'm gonna add another floor. Now you would also have a switch to turn everything, right? So over here I have demonstrated that. So if this is our house, we would, so I'm using the parallel connection. Let's say this is our battery, or where the electricity comes from, to our house. So for each switch, you will need first each personal switches, right? So I added a personal switch. Let's see. So I added a personal switch over here. So for everyone, I have added a personal switch. PS denotes personal switch. Then personal switch. Okay, so every appliance now has a next thing we have the whole room switch. So if this is a wire and going through this, so if you want to turn, if you don't want electricity to pass on any of these wires, so we'll make this into one wire, connect those two in one wire and add a switch over here. So if this switch is off, current won't pass through any of these wires and thus the whole room will be off. Understood this, right? Okay. So now for flow switch I'll add another. So if this is, and then LED over here, and then we've got
Take another pen.
okay, I guess this is okay. So now these are the room switches, right? Now to turn the whole room, the whole floor off. So let's say this is floor 2, this is floor, what? Floor 2. To turn the whole thing off, you'll make this also into one wire, right? And then put another floor switch. Now you'll put a floor switch. So if this is off, current won't go anywhere. Understood this? Any questions till now? No?
Punita, are you really understanding what he's talking about? Really? Okay.
Okay. So this is floor switch for floor 2. Now I'll do the same thing. So let's say this is the floor switch for floor 1. Okay? Now to turn all the floors off, so that means to turn the whole house off, you make this into one wire and then add a house switch over here. So now if this is off, nothing will work, right? And so this is connected to positive terminal, and like right now if the connection like this, nothing will work. And now for the negative terminals, all the negative terminals will come to the battery. So let's say our battery is our, like we are getting this from somewhere, okay, and we are getting two wires, like you won't add a lot of wires to the main power supply. So this is our power supply, these two wires are coming, you connect this wire, let's say this wire I'm denoting by F plus, and we connect it to this wire, okay, and the negative one will be connected to all, we'll divide this into 8, 1 2 3 4 5 6 7 8, and these all 8 will go to the appliances. So over here I have done the same. So each appliance has its person switch, and you understood the connections. Then each room has a room switch, okay, and each floor has a floor switch, and each floor has a house switch. And now the porch light, okay. So basically, if this is our switch with 3 terminals, yes. So you know that the switch has 3 terminals, right? So one would be for the battery, middle one should be for the battery, and then the side one over here, let's say I've connected this. So this is our house main switch, okay? House switch. If this is our house switch, so this wire will be connecting to the floor switches, right? As explained over here. And now I've connected this other one to a porch light. So basically how a switch works,
It's a two-way switch which you used.
yeah. So if this is our switch like this, what happens is inside the switch, the knob is connected to a metal plate, okay, and the terminals are like this. So if the switch is over here, it will connect these two terminals and make this work. As the battery is over here, the battery will flow like this and go like it. But if this is turned this side, this will be off because it's not connecting anymore. But if this will be over here, then this will go over here. Did you understand this? No? Did you understand it? No? Okay. So
That's fine. That's fine. Okay. Anything else? Yes.
yeah, so now, so over here, this is also connected to our negative. So this is Okay. Any questions till now? Yes.
Why are there two batteries connected?
So basically, like in the starting, nothing was working. Okay, so I thought that one battery over here. So let's say this is one battery. If this is one battery, this is not giving enough power to power all the appliances.
Power what, like how many punches before you are dead, like that? What does power mean? Like
So it's not giving enough voltage. So let's say it has the voltage of 2.3 or something, and each motor requires at least 1, and each LED requires 0.5. So when if this is a parallel connection, right? As explained before, in parallel connection, the current gets divided, but the voltage does not. So before I thought the voltage is also getting divided. So right now I think it should work with only one line. But so like if 1 and 1.5, so and these have four motors and 4 LEDs, right? So you need a lot of voltage. But I think it could work with the one LED also. I've just used two LEDs to maximize the voltage and it also makes the motors go faster and the LEDs brighter. Okay?
so what if you had 3 or 4 or more batteries? What will happen?
If you had more batteries, theoretically it should go faster, but there's always the chance of it getting short circuited. That means
That is not short circuit.
Okay.
Short circuit is a direct connection between negative and positive. It's not a direct connection. There is a motor in between. Why are you calling it short circuit?
Then it could.
Too much voltage and too much current will produce obviously excessive heat. Your motor hardware should be able to take it.
Okay.
That's simple.
And
Don't say things before thinking. Kuch.
That's why if you use 3 to 4, it could damage your motor.
So, like in real life, how does government control this? Because I don't think sometimes the light is very bright and sometimes
Yeah,
it's very
so on my thing, so let's say government is giving this battery, it has like 100 volts or something, okay? Then like if we know how much it's producing, you can put that much resistor. So basically what a resistor does, it changes electrical energy, produces heat energy.
Instead of resistor, we are using transformers. We are not using resistor. Resistor literally wastes away the energy. वो wastage करता है. हम transformer use करते हैं.
Okay.
ट्रांसफार्मर वोल्टेज को रेगुलेट कर सकता है. We can ऐसा कम वोल्टेज को हाई में कन्वर्ट कर सकते हैं, हाई को लो में कन्वर्ट कर सकते हैं. So obviously all your machines do not run on 220 volts.
Okay.
But the supply we get is 220 volts. Your mobile doesn't run on 220 volts. ठीक है, 5, 10, 6 वोल्ट पे मशीन्स रन होती हैं. तो उसके लिए मैं ट्रांसफार्मर लगाऊंगा. जो हमारा अडेप्टर है ना, द अडेप्टर और चार्जर जो प्लग में जाता है, उसके अंदर ट्रांसफार्मर होता है. खुले हुए पड़े मैं दिखा दूंगा.
Okay, so basically what a transformer does.
This was in your research work. I think it is in Tesla for research work.
So basically what a transformer does, it allows only a limited power, a limited voltage to reach the appliance, and thus it does not damage it. Okay.
Okay. So every appliance's switch or something has its own transformer.
होता ही है. इनफैक्ट वहीं क्यों तुम्हारे जो बिल्डिंग के बाहर भी लगा होता है ना बड़ा ट्रांसफार्मर, इट इज कन्वर्टिंग थाउजेंड्स ऑफ वोल्ट इनटू 220 वोल्ट्स.
जो ट्रांसफार्मर अगर मतलब उसमें कुछ प्रॉब्लम आ जाए
तो प्रॉब्लम होती है. अगर उस ट्रांसफार्मर में कुछ प्रॉब्लम हो जाए
कैसे होती है? मतलब कि ज़्यादा पावर आ रही तो वही
यार, पहले तो ज़्यादा पावर आना इज नॉट द करेक्ट लाइन. ऐसे सोच कि जो ट्रांसफार्मर का हार्डवेयर है वो भी लिमिटेड कैपेसिटी का है. यू नो, if the wire is thicker, it can sustain more heat, or it will generate lesser heat. Point is that at every point we have to understand कि जैसे वो ट्रांसफार्मर है उसकी यूटिलिटी क्या है, वो किस चीज़ के लिए बना है, तो उसका हार्डवेयर उसी तरह से डिज़ाइन होगा. फॉर एग्जाम्पल दिस मोटर, अगर इस मोटर को मैं एक्चुअल पंपिंग के लिए लगा दूंगा, ठीक है, obviously it will not sustain ना. Hardware is designed in a way कि it can sustain that much of current, it can sustain that much of heat. वो उस तरह से किया जाता है. उसके बाद भी प्रॉब्लम होती है, ट्रांसफार्मर फटते हैं, जल जाते हैं, होता है. ऑब्वियसली वो नहीं करना था. आपने स्पेसिफिकेशन से ज़्यादा करंट पास किया. whatever reasons are there. So खैर, I have a question, Katish.
Yes.
If there is a situation where suppose these 4 rooms are 4 separate houses, 4 owners. These are
Okay.
4 separate houses. There are 4 owners of each house. If the power which is supplied is limited, is fixed, suppose let's say 20,000 joules per second. ये 20,000 joules एक सेकंड में आपको पावर मिल रही है, ठीक है, एक सेकंड में 20,000 joules you will get. That should mean कि जितने भी ओनर्स हैं उनका कलेक्टिव कंजम्पशन शुड नॉट गो बियॉन्ड 20,000 joules per second. जो एनर्जी मिल ही नहीं रही है उसको यूज कैसे करेंगे, है ना? So that should mean there. Do you think there should be some kind of arrangement where the government makes sure that people do not try to extract more energy per second or per hour or per month, whatever is the duration, than what is being given to them from wherever it is being produced?
Yes. There should be a limitation for what the owners can use.
Yeah, I'm trying to understand why is that.
Because, like, I think so if an owner is using, let's say, if you're getting 20,000 joules per second and he's using 10,000, what's left for the other people? So the government has to ensure that every owner gets its supply, right? But if one person is taking so much that the other people are not getting
So
it
how
at all.
how this person can take so much? That's what my question is. So one day he is taking 10,000 joules for a day.
Yeah.
The next day he is taking to 20,000 joules for a day. The very next day he is taking 5,000 joules for a day. इस चीज को कैसे मेंटेन करेंगे? क्योंकि कोई कितना भी ले सकता है. फिर मैं यहाँ पे इस रूम में 4 AC लगा सकता हूँ. Suddenly मेरा कंजम्पशन इंक्रीज हो जाएगा.
Yes.
So will that be a problem?
Yes.
If that is a problem, what is the solution to this? Because अगर ये प्रॉब्लम है तो ये हमारे यहाँ डेली हो रहा होता, बट नहीं हो रहा है डेली. देयर हैज टू बी सम कंट्रोल जो प्लेस में है जिसकी वजह से लोग ये नहीं कर पाते हैं.
So, like, what I think is for each house, let's say this is our house, there is a limited supply. Like, you give only, like, let's say if you give 5,000 joules per second, and you're giving this to each house, so it does not.
What is that control? So that's what I'm saying. When you apply for an electricity connection, you have to specify कि मुझे कितने किलोवाट आवर का कनेक्शन चाहिए.
Yes.
कितने किलोवाट का कनेक्शन चाहिए. किलोवाट का मतलब है कितना एनर्जी पर सेकंड या पर डे जैसे भी डिफाइंड है इन द टाइम फ्रेम, मैं उतना ही यूज करूंगा मैक्सिमम, और उस हिसाब से आपको कनेक्शन मिलता है. उसी हिसाब से आप ये सॉकेट्स बना सकते हो जो दीवारों में है. यू कैन नॉट मेक too many sockets. It will just prove to them that you are using too many machines.
Yes.
Or too much, your consumption is too much. They will fine you for this. Although electrician को बोलोगे तो मना नहीं करेगा, because वो गवर्नमेंट का नहीं है. You understand?
Yes.
Because in totality, wherever power is coming from, wherever the energy is coming from per second, the total energy coming per second, you obviously cannot move beyond that. Your consumption cannot go beyond that, and it has to be divided between several households and people. So जयपुर को जितना टोटल उसका कंजम्पशन होगा, मिनिमम उतना एनर्जी पर सेकंड, अगेन पर डे पर आवर, जो भी तुम बोलना चाहो टाइम फ्रेम में, दैट हैज टू बी देयर. इफ इट इज नॉट देयर, कहीं ना कहीं इलेक्ट्रिसिटी कट करना पड़ेगा. यू गेट इट? या? And it's not the total energy, it's the total energy in a time frame. You get it?
Yes.
ठीक. Anything else किसी को पूछना है? कुछ तुम पूछ रहे थे ना? तुम पूछ तो रहे थे ना कि करंट का कुछ something.
What is exactly voltage?
Okay. I'm just going to grab a little part so I can explain. So, if let's say this is an electron, these are many electrons. Okay, you know what an electron is, right? So
एक सेकंड.
so these electrons are negative charged particles, negatively charged particles. Okay. So now when a negative reaches a negative, it's just like a magnet. Let's say if it's positive and positive ends of a magnet, they repel each other, right? Everybody knows this, right? So that's what an electron does. So let's say these are electrons, and these are their gravitational fields. So there is a
Electrostatic fields
electrostatic fields. Okay, sorry. Electrostatic fields. They will start
or
repelling.
electric field. Electric field.
They will start repelling each other. So let's say this electron, this will repel another electron, which will repel another electron, and so on and so forth. Okay? Do you get that? Okay. So basically this is the voltage. Okay. So if this is a battery.
You have to repeat the last two sentences. He was not looking.
Okay.
Electrons.
So basically, when a negative and negative reach, they repel each other. Okay, they repel. So let's say this is an electron. This will repel another electron, which will repel another electron, and so on and so forth. So after this, the electron will start drifting. So let's say if this is a battery. Over here it produces 2 electrons, and this happens. So let's say this is our load. Okay. Electrons are flowing because of the repelling I just told you. Everybody gets it now? Flowing. So now after these all flow, okay, they will have to come at a certain point. They can't just disappear into thin air. So after they come out here. So when this has 3 electrons and they are repelling each other, so they're moving. And here also there are 3 electrons which are also repelling each other. There will be a certain point when these two will give the same repelling force, and nothing will happen at all.
Not making sense, Tatish. You're just too quick and too fast for things which are not visible.
Okay, sorry. Okay.
Why are you saying sorry?
Okay, let's say this is a battery, okay? And this is a load, positive and negative. This is producing 2 electrons. This is not producing any electrons at all. So after these electrons are produced, they will start repelling each other, right? Okay. So after they start repelling each other, we connect these. They will start drifting because the bios has electrons. They keep on repelling, and then they will start drifting. Okay, everybody got this? Then it's gonna come over here. Got? So yes.
Why does this start producing electrons when we connect the terminals with some load?
That's the next question. No, let him answer this.
Yeah, I'll tell that first. So right now these are drifting, okay? So and over here they will stop drifting and come at a certain space, right? So now there will be a certain point where these are also a lot of electrons. They are repelling each other with the same amount of force that this is giving. Okay? So right now if these are balanced forces, nothing will move, right? Because if they have no place to go, so they will just start still, and this is when a battery gets discharged. Did you understand this?
Yes.
Now your question was?
I was asking why does it start producing or drifting of the electron starts when we connect the terminals with the load? What happens when a battery is not connected to anything? What happens?
So if a battery is not connected to anything, then the electrons don't have a place to go. So they will just stay on here.
But वहाँ पे कोई बैग नहीं है electrons का. कोई बैग नहीं है कि they do not have any place to go. Is there a bag or something?
No.
जब हम connect करते हैं, then these electrons starts to come into picture.
No.
Oh, they are there previously only. Then there is a bag of electrons. Is it?
No.
Then where are they when we are not connecting it? That is what he is asking. कि वहीं से तभी produce होते हैं क्या जब हम connect करते हैं? क्योंकि उसके पहले कहाँ पर हैं फिर electrons? That is what he is asking, ना? Got it? ये पूछ रहा है ना?
So I think after connecting the wire, there becomes a potential difference between this, and that's why it starts
But I'll
producing.
refine his question. Why does that chemical reaction starts only when we connect the wires? वो chemical reaction तो पहले भी हो सकती है ना? Why does it start later when we connect them? Just asking. और मैं जो बोल रहा हूँ शायद वो गलत हो. Chemical reaction complete हो चुकी है पहले. I don't know. You tell me. Anyways, सुनो ठीक है, you can answer that later to him. But I don't think this question अभी बता पाओगे तुम कोई. ठीक है, but anything else, any other questions? Questions? Sure. ठीक है. ठीक है. I have more questions. मैं बाद में पूछता हूँ तुमसे. अभी बहुत लंबा हो गया है, so we have to. Okay.